If we start, for instance, with sympathetic co-transmission, here we see both ATP and noradrenaline coming out, but ATP acts on, as we'll see later, ion channel receptors to give excitatory junction potentials and a fast contraction, whereas the noradrenaline works through alpha-1 receptors, G-protein coupled receptors, which lead to a slow contraction. NPY, which is part of the chemical coding, as it's called, in co-transmission, in sympathetic nerves contained in large granular vesicles, doesn't act mostly as a genuine co-transmitter, but rather either as a pre-junctional or post-junctional neuromodulator. For parasympathetic nerves, we know that acetylcholine and ATP in the urinary bladder are co-transmitters. In fact, in animal models, in all the experimental models used in the labs, about 50–60% of the parasympathetic response, contractile response of the bladder is purinergic. The rest is cholinergic, mediated by muscarinic receptors. And then there are sensory motor nerves, which turn out to be extremely important. These are the nerves involved in the axon reflex, which was identified in the 30s. Here, what happens is that the sensory collaterals release CGR, calcitonin gene-related peptide, substance P, and in many of them ATP as well, to cause vasodilatation of skin vessels, but also of all the vessels in the body, and often in the skin, the flare reaction that follows.